Hey guys, let's go ahead and talk about some more graph analysis questions. So I'm going to do 2015, 2016 today, and just take a look at those, okay? So we want to see, hopefully you've been following along with us, but the patterns come up the same type of questions are being asked. So this one, it says, the figure above shows the graph of f prime, the derivative of a twice differentiable function on the interval from -3 to 4. The graph of f prime has horizontal tangents at x equals -1, x equals +1, x equals, so let's see, -1 horizontal tangent, +1 horizontal tangent, and +3. The areas of the regions bounded by the x-axis and the graph of f prime on the intervals from -1, 2, and 1, 4 are 9 and 12. So they're saying the area is 9 and the area is 12. Okay. Now, that's interesting. The area is 9, but remember the integral is actually going to be negative because it's below the x-axis. Okay, but we'll tackle that as we go along. Part A says find all the x-coordinates at which f has a relative maximum. So part A is the easiest part. Remember, guys. So what is the key word here? Maximum. Now remember, this is the derivative, and that's the one they're going to give you more than likely. Okay, now remember, all of these are the slopes that are connected with a smooth line. So right here, all these slopes are positive. Why? Because they're above the x-axis. So that means the graph is increasing here, and then it's decreasing here. All of these, how do I know the function is decreasing? Because all of these slopes are negative. They're just connected with a smooth line here. They're all negative. So it's increasing here, okay, because the slopes are positive. They're just connected. And over here, all of these are slopes that are negative. So it goes from positive to negative. Okay, if you want to think about it as a number line at -2, right? So to the left of -2 is going up. To the right of -2, the slopes are going down, are negative. So there's your maximum. Okay, now how would you say that? Well, you would say that f has a relative maximum at -2. Why? Because f prime changes from positive to negative at x equals -2. Okay? That's all you would do. That's all you would say. Okay? Part B. On what open interval between -3 and 4 is the graph both concave down and decreasing? So remember, didn't they ask a similar question in 2013, 2014? Yes, they did. Yes, they did. So remember, concavity, you're talking about the second derivative. Decreasing, you're talking about the first derivative. Increasing, decreasing. So we know here, right, this is the first derivative. It's the graph is increasing here, okay? And the graph is decreasing. All of these negatives, that means it's decreasing. All right. What about concavity? Now, where is it concave down? We're actually looking at the graph and we're analyzing it. So here, all the way down to here, you see that? The slope of this line here is negative. So all the way from here, from -3 to -1 is concave down. Why? Because it's going down. And then from -1 all the way to +1, you see it's going up, right? So the slope is going up. So that means it's going to be concave up in this little section. And then it goes from 1 to 3 is going to be concave down. And then from 3 to 4, it's concave up. Now, it's asking where is it both concave down and decreasing? Okay, so the graph is decreasing all of this section right here. So now where is it concave down? Well, it's concave down. If you notice, it would have to be from -2 to -1. And then from 1 to 3. Okay, so from -2 to -1, and then from 1 to 3. So you would write -2, the open interval, -1. Okay, you wouldn't include it because remember at -1, what happens? You have a horizontal tangent. It's 0. Okay, and then you would have and from 1 to 3. All right. So how would you say that? You would just say the graph of f is both concave down and decreasing where? And then you would put this and this. Okay. And you would just you can say because f prime changes from, now you just leave it like this. You would just leave it like this, and then that should be your reason. Okay, now I would actually recommend labeling it. Okay, you can say it's concave down if you want to say that. Okay, it's concave up. You know, remember these are people grading it. These are human beings. These are calculus teachers. So I think they'll understand CD, concave down, concave up. If you want to write it out, put an arrow. You know, by all means do that. A lot of us are more visual than anything, so I think that would be helpful to them. Whatever you think is going to be helpful for them to understand what you're demonstrating, okay? But that's it. Okay, so you notice, hey, the last 2 years in 2013, 2014, now 2015, they asked the same thing, right? Maximum, they asked the same thing. Part C. Find the x-coordinate of all points of what? Inflection for the graph of f. Give the reason for your answer. Okay. Okay. Now remember, points of inflection, you're talking about the second derivative. Now remember, let's just go ahead and do a number line. Now, how do we know how to find the point of inflection, right? We take the second derivative, set it equal to 0, and whatever let's say that's a, right? It changes concavity, right? From negative to positive, right? It changes from maybe concave down to concave up. Well, hey, we can already just look at it here, right? Look at it here. So it goes from concave down to concave up. Point of inflection right there. Concave up, concave down. Point of inflection right there. Concave down, concave up. Point of inflection right there. So your points of inflection, okay, are at x equals -1 and +1 and +3. Why? And you would just say because it changes concavity. It changes concavity. And you can just go, you can say it changes from concave down to concave up, and then concave down to concave up. You can say that, okay? Or you can just say it changes concavity from concave down to concave up. I think that should be fine. Okay, guys? But when I see this and you demonstrate concave up, concave down, you know, that's perfectly fine. And if you want, you can actually draw a number line here, and you can put -1, +1, +3, okay, and then do it that way as well, right? So you can do this right here, f double prime of x. If that's easier, you can put, right, -1, and then you can put +1, and then +3, right? So to the left of -1, right, concave down, negative. From -1 to 1 is positive, concave up. All right, so concave down, concave up. And then from 1 to 3, right, that's negative, concave down. And then from 3 to 4, okay, it's concave up. So where does it change concavity? At all 3 points right here. And if you draw this, sorry about that, if you draw this and explain it, I think that'll give you all full points. That's perfectly acceptable. Okay, so that's part C. Let's go ahead and do part D. Okay, given f of 1 equals 3, that's our initial condition, write an expression for f of x that involves the integral. And it says find f of 4 and f of -2. All right, so let's think this through. Let's say you don't know how to do it. Start off with this. Okay, well, how am I going to find this? Okay, how do I find that? What do they give me? The derivative, right? So how do I find f from the derivative? That's right, you're going to take the antiderivative. Antiderivative f prime of f of x, right? Well, where do I go from? From where? What's your initial condition? X equals 1 to where? Well, what do they want you to find out? 4. There you go. So now you go from 1 to 4. And what do? You do your fundamental theorem of calculus. So you do the antiderivative of f prime is f. f4 minus f1. So now what do? You rearrange it. You take, you're going to solve for f of 4. So you're going to have f of 4 equals, take this minus f of 1 to the left, and then this is a plus, the integral from 1 to 4 of f prime of x dx. Okay? So now what do? Well, what's f of 1? Well, they tell us, right? It's 3. Nice. Okay, now the integral from 1 to 4 of f prime of x dx. Well, what does that mean? Well, they give us f prime of x, don't they? So what does this mean? Remember, we talked about it. This means the area underneath the curve, or the area between the curve and the x-axis. So between 1 and 4. Between 1 and 4. Now they told us the area is 12. Now be careful. The area is 12, but the integral is not 12. The integral, because below the x-axis, that's going to be negative 12. So be careful with that when they ask you, okay? You don't go to Home Depot and say, I want negative 12 square feet. They're going to think you're crazy, right? But the integral can be negative, all right? So f of 4 is going to equal to negative, what is that, negative 9? Yeah. All right, we found f of 4. So now what do I do? Same thing with f of negative 2. What do? Well, you're going to take the integral of f prime of x dx from where? What's our initial condition? From 1, okay, to where? What do they want us to find? Negative 2. Okay, we do that. So now we get f of negative 2 minus f of positive 1. They want us to find f of negative 2. So f of negative 2 is equal to, take this to the other side, becomes f of 1 plus the integral from 1 to negative 2 of f prime of x dx. All right, f of 1 we already know is 3. Now you notice here it goes from 1 to negative 2. I'm going to reverse the limits of integration just because I like going from low to high. And then just, it makes it easier for me just because I'm going right to left. Now just be careful of that, okay? Be careful of that. And you notice how they're testing your understanding of the limits of integration. All right, so now what's the integral from negative 2 to 1? From negative 2 to 1. It is 9, but because it's below the x-axis is negative 9. So it's going to be 3 minus negative 9. Okay, that means your answer is 12. F of negative 2 is 12. And then you have it, guys. There you have it. So hopefully that makes sense. And if you can notice, they're continually asking the same type of questions. All right, let's go ahead and do 2016. Okay. Again, look at what they give us. The derivative, right? All right, because if I take the derivative of this guy, I end up with this. The figure above shows a graph of the piecewise linear function. So for negative 4 to 12, the function is g is defined by this integral. Okay, good. All right, and then what does it tell me? Part A, does the g have a relative minimum, a relative maximum, or neither at x equals 10? You see how they ask the same type of question? They're asking about minimum, maximum. Now remember, what are we talking about? Okay, these are, remember, these are your connected slopes by a smooth line. Well, not very smooth, but it's jagged. But these are just connected slopes. So look at, see here, the slopes are negative. So the function is decreasing. So from here to here, all of this, the slopes are positive. So it goes here from negative to positive. Okay, see right here it doesn't cross. So don't be fooled by that. It doesn't cross, so it's neither. Okay, and then from here the slopes go from positive to negative. Okay, all right, it goes from positive to negative. All right, so if you notice, and what you can do also is a number line as well. All right, so let's do a number line here. All right, what are my critical points? This is my derivative. What are my critical points? Right, when the derivative is equal to 0, it's equal to 0 here, 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 and here. And I'm just going to use all of them just to kind of show you and demonstrate it to you, just so it makes sense, okay? So at negative 2, and then we have at 2, and then we have at 6, and then we have at 10, right? So to the left of negative 2, negative. To the right, positive. At 2, to the left, positive. To the right, positive. Okay. To the left of 6, it's positive. To the right of 6 is negative. Okay. To the left of 10 is negative. To the right of 10 is what? Negative. So you see, you have this negative going up, going up, going down, going down. So where, now look at it, where does it have a relative minimum, maximum, or neither at x equals 10? Okay. You see that? So at 10, it's neither relative minimum or maximum. Why? Because the graph of f does not change sign, period. And that's all you would do. That's it, guys. And they were asking specifically at x equals 10. All right, but notice what I did. When I see minimum, maximum, okay, I'm thinking, what do I do? Okay, derivative, set it equal to 0, critical points, number line. Okay, here's my derivative. What's set it equal to 0? It's 0 here, 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 here. Cool. Then I do what? My number line. And I do, is it increasing, decreasing, whatnot? And then at x equals 10, nothing happens. Part B, does the graph of G have a point of inflection at x equals 4? Point of inflection. You see that? Didn't they ask that last year as well? 2015? Yes, they did. All right, what's a point of inflection? You're talking about the second derivative. We're talking about x equals what? 4 right here. We're talking about this guy right there. Okay, now remember, second derivative. Okay, so you got to at x equals 4. So here, now take a look at it. So here it's going what? The line is increasing, isn't it? The slope of f, which is the derivative, the slope of this guy's going up. So this guy's going to be concave up. The second derivative is up. And this guy's going what? Afterwards it's going what? Down. So it's concave down. So yes, there is a point of inflection. Okay? Okay? And you would just go ahead and say G has a point of inflection at x equals 4. Why? Okay? Because it the graph of f increases and then decreases, okay, or it goes from concave up to concave down. All right, and that's it. And you would say that g prime of x is the graph of f is a derivative of g. Okay, but all you got to do is see how you say it's concave up and it's concave down. And you would say G has a point of inflection at x equals 4. Why? Because it goes from concave up to concave down. And if you want to draw another number line, because you're used to that, right? You can put 4, right? And you can put positive because the graph is going up. And then you can put negative. So then right here you can put concave up, concave down. Boom. And then this you can put second derivative, f double prime. All right, and you're just analyzing the graph because it's going up and it's going down. And that's perfectly fine. Okay, part C. Okay, find the absolute minimum value. You see this? Look at this, value. Okay, so no longer are they just asking for the minimum, but actually the value, the amount, okay? So, and then we have find the absolute minimum value and the absolute maximum value of G on the interval between -4 and 12. All right. So remember, when we're talking about minimum, maximum, what are we talking about? First derivative, set it equal to 0, number line, and then we do our arrows, right? Well, actually, I kind of jumped ahead. Maybe my mind was working too fast, but I kind of did it right here, all right? So look at critical point, or candidate. Okay, critical point right here. Boom, right? Because the first derivative is equal to 0. Okay, and I do my number line right here. Okay, so I know I have, right here, I have a min. Right here at x equals 6, I have a max right there. Okay, does that make sense? So that's the minimum at x equals -2, at x equals 6. But now what's the value? What's the value of the function when I plug in 6? So I have to figure out, guys, g of -2, g of +6. But remember, they're asking for the absolute minimum value. That means the whole stinking graph. So I have to figure out the beginning. What's the beginning? It goes from -4. And then what's the end? It's at 12. Okay, so you have to figure out all these values. All right, and I say, well, how am I going to figure out g? Well, don't they give you a representation here? Yes, they do. So let's go ahead and do it. Let's say you don't know it says g of -4. And let's just play around with it. It goes from 2 to -4, f of t dt. Okay, All right. Now I don't like this. I like to put the smaller value on the bottom. I'm going to reverse my limit of integration. So from -4 to 2. Okay. If you don't need to do that, go for it. Don't do that. Okay. All right. So from -4 to 2. Okay. So from -4 to 2. Where's -4? -4 to +2. Now remember, we're doing the area underneath the curve. So from here to here, we have a triangle. So 2 times 4 is 8. Half of 8 is 4. But because it's below the x-axis, that's a negative. From here to here, that's 2, that's 2, that's 4. So 4 times 4 is 16. Half of 16 is 8. But because it's above the x-axis, that's a positive. All right. So from -4 to 2, 8 take away 4 is 4. But because we have a negative in the front, we reverse the limit of integration. This becomes a -4. So g of -4 is -4. All right. Now we do the same thing with -2. All right, let's do -2. So I'll just go ahead and do that. G of -2 is equal to the integral from 2 to -2 of f of t dt. I want to go ahead and reverse it. So it goes from -2 to 2. Make sure that's a negative in front of the integral. All right, now I go from -2 to 2. So from -2 to 2, I already found it. It's +8. Cool. Negative. Now it's +8. All right, so that means g of -2 is -8. Nice. There it is. Now, let's keep going. Now we got to go do g of 6. Okay, g of 6. The integral from 2 to 6 of f of t dt. So now it gets a little bit easier. Oops, there it is. So from 2 to 6. So let's look at it from 2 to 6. So from 2 to 6, this distance is 4. This distance is 4. So 4 times 4 is 16. Half of 16 is 8. And because it's above the x-axis, that's a positive. So g of 6 is 8. That makes it easy. And the last one, g of 12. So let's go ahead and move it here. So g of 12, same thing. You can do the integral from 2 to 12 of f of t dt. All right, so from 2 to 12, we got to go from 2 all the way to 12. Okay. Now, just something you can see, these two triangles are kind of similar, right? Actually, they are congruent. And you can see this one's above, this one's below. And this is actually going to be -8. So we got 4 times 4 is 16. Half of 16 is 8. But because it's below the x-axis is -8. And this one here, this is 2 times 4. 2 times 4 is 8. Half of -8. Half of 8 is 4. But because it's below the x-axis is -4. All right. So now, let's go ahead and from 2 to 12. So these cancel out. And then you have -4. So g of 12 is -4. All right. So now, where is your maximum value? Where is your minimum value? Your minimum value is at g at -2. So that's your minimum value. Where's your maximum value? Okay, your maximum value is right there. Yeah, at 6. And there it is. Okay. All right. Last part. Part D. Okay, part D is sometimes the hardest question, just kind of interpreting it. And it seems this is the first year they kind of threw something interesting. But it says, for the interval between -4 and 12, find all intervals for which g of x is less than or equal to 0. So what does that mean? That means this guy is negative. That's what they're telling us. It's negative, right? So what do we know? Well, you want to do these breakage points right here, 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 okay? And you notice, okay, you notice here, let's start out going from g of 2 because that's what we start off from. G of 2. What's g of 2? G of 2 is what? 0, right? Because if you think about it, if you go to the integral from 2 to 2, well, it's not changing. Whoops, I'm sorry. From 2 to 2, that's nothing. That's just 0. Okay. And then, so g of 2 right here is 0. Okay, well, what about this guy? What's g of 6? That means we go from 2 to 6. Well, that's +8. Okay. What about this guy right here? What about g of 10? What would that be? Well, that means you would go from 2 to 10. The areas, here's 8 and here's negative 8. So that would be 0 again. Okay? And then, what about the end? Okay? And you would notice here this area is, let's say g of 12. That would be negative 4. So, from 10 to 12, the value of g of x would actually be negative. Okay? Because from 10 to 12, right, we find that area, that's negative 4. Okay? And then we do the same thing. We do the same thing going backwards. Okay? And I'll just leave it like this. We'll just go backwards. So when we're going from 2, right, we're going to negative 2. Well, from 2 to negative 2, okay, see how I'm going to the left? I'm going backwards. That would actually be negative 8, right? Negative 8. Okay? So g of 2 is 0. G of negative 2, well, what is that value? If you don't know, let's just go ahead and do it. G of negative 2 equals the integral from 2 to negative 2. And didn't we do that one already? Yeah, we did, huh? Look at that. G of negative 2, that's negative 8. We found it. Okay. So this guy is negative 8. Okay. What about G of negative 4? Did we find G of negative 4? Yeah, we did. Look at that. Negative 4. Cool. So where is it negative? It looks like it's from negative 4 all the way to positive 2. Okay? So from negative 4 here, this is negative, and then all of this here. Okay? So from negative 4 all the way to positive 2. That will be your negative. Okay, from negative 4 to positive 2. Now be careful. I know it says positive 8, but remember, we found the value of negative 2, right? Negative 8. The value of 2 is 0, because here doesn't travel. But remember, we went from 2 to negative 2. We went backwards. See, that's how I get that negative. We went backwards. So this is actually a negative, and this would be a negative. So it's actually g of x is less than or equal to 0 for the interval between negative 4, okay, and 2, okay, and from 10 to 12. All right, guys. That was a little bit tricky to understand, but hopefully it makes sense. And what do? We use the integrals. Okay, guys, so hopefully they're starting to make more sense. And good luck, and I'll see you guys next time.